Okay, we're going to be talking today about pi, but not this kind of pi, not the kind of pi you think about when I say pi. We're going to be talking about pi that Archimedes, back in the 3rd century, developed. So we're going to be talking about pi. Pi equals 3.14, okay? That's it simplified. This is its symbol. So pi has 3 ways that we can look at it. We can look at it as a word, we can look at it as a decimal, as a numeral, and we can also look at it as a symbol. So when you get into your upper grades, you're going to see this a whole lot because this will be in the equations that you'll be working, okay? Today we want you to take that strip of paper that you have, okay? And I want you to do just like the young man in the picture here. Wrap it around your head. Take a measurement of your head. See how he's measuring his head right here? Kind of take it off your head gently and look at that. Okay, it's a circle, isn't it? Now, okay, so this is pi, and we're going to talk about how we're going to use that with a circle. And a circle can be something else. A circle can be called a circumference, okay? And a circumference, it is the outside of a circle or a circular object, okay? And the radius is from the center of the circle to the outside. So when we use our formula, because we're going to learn a formula today for finding the circumference of a circle or any circular object. Now, why do you think it's important that we know how to do that? Why do we even care what the outside of a circle is? Why? Somebody have an idea? Okay. You forgot?
What is the question again?
Huh?
What is the question again?
The question is, why do we care about the outside of a circle, the measurement of it? Why would that be important to us? I mean, it's just a formula. Why do we even care that we learn it? Sir?
So if you find a perimeter of a circle.
Okay, so you can find the area inside. You said perimeter. When circumference is the same thing as a perimeter, but a perimeter is like on a square. Circumference is on a circle. Let me ask you something. What if you were an astronaut going into outer space? Someone has to figure your orbit, don't they? You think about the men who went to the moon and how they went around behind the moon. What if we didn't know how big the moon was? What would happen if we didn't know how big it was? And even worse than running out of gas almost would be crashing into it. Because if we didn't know how big around it was, we wouldn't know how far to go out, would we? So you see, even down to the plumber who comes to your house, if you've ever built a new house or had a stack or something put on your roof or a pipe, he's got to know how big to cut the hole, doesn't he? He's got to know the circumference of that pipe. Or else if he cuts it too small, is it going to go through?
No.
No, if he cuts it too big, what's going to happen?
Leak.
You could have a roof leak, couldn't you? So we use circumferences all the time, from very sophisticated like NASA to very elementary and simple like a plumber would use it. So it's important that we know it. Now this is going to be our formula that we're going to use right here. It is pi equals 3.14. So circumference is our C, okay? And I want you to write this at the top of your page. C equals 2 times pi times the radius. And on this circle right here, it's a 3 inches on the radius, which we talked about right here. So if you take 2 times pi, which is the first part of our formula here, there you get 6.28 times 3, which is our radius, you get 18.84. So we know that the outside of this circle, the circumference of this circle, is 18.84. Okay? So this is how it would be worked. If you were to write it out in a formula, like algebra, how many of you are in a math class where you've used any algebra at all? Have any of you used any algebra? Okay, good. So you understand what I'm talking about then. When you've got your little parentheses, that shows that you're going to work through this problem 2 times 3.14 times 3 again. So that's that formula. Let me see if I can pull up, Melissa, how will I pull up the calculator that's down here? He needs a piece of paper? Okay. There you go. And a strip. I'll leave you with a strip too. And I want you to look at, we're going to do a simple one. I want you to look at Pluto right quick, okay? 2 times what? Tell me how to do this. Somebody tell me what I need to do. What's the first step in this problem? Okay, 2 times, where's that? 3.14. Okay. Here, did I
didn't put the two.
I didn't put the 2? Okay. Is it there now? There, okay. 2 times, is it there? 0.14. Okay, so we got the first part. All right, what do I do next? On Pluto, what am I gonna put in? What am I gonna do? What am I gonna do? I'm gonna add,
By 3.
I'm gonna do what?
Times 3. Multiply by 3.
Multiply it by, for Pluto, not 3, that was our radius right here. For Pluto, look on your paper.
1,200.
1,200,
Yes.
just 200? There we go. So, to go around Pluto is about 7,536 kilometers. So this is in kilometers. And what does that tell you about Pluto? That it's small. It's one of the smallest planets. That's why I chose it. So if you take your pencil and paper, you could go through and figure every planet on that piece of paper and how big around it is. Some of them would be very big, wouldn't they? But you can see how important that is that we know these things and can work these formulas. But anyway, do y'all get the idea of what we're talking about there? Okay, good deal. I appreciate your time. That's really the end of it. I just want to go over with y'all how you figure, use a formula to figure out the circumference of a circle using this formula right here, which you now have at the top of your sheet. Okay? Thank you very much.